So these problems also say solve. So for number D here, what I'm going to do is I'm going to look at all of the denominators here. So I have a 3 and I have a 7. So the LCD of 3 and 7, and the smallest number that 3 and 7 go into, is 21. So that's what I'm going to pick. And what I'm going to do with that LCD is I'm going to multiply both sides by that LCD, which is 21. So I'm going to say, okay, this side I'm going to multiply by 21, and this side here I'm also going to multiply by 21. So that's how I'm going to start this problem. So that's going to give me, so now notice how this works. This 21 and this 3 simplify. So 3 goes into 3 once, 3 goes into 21 7 times. So really what I have here is 7 times x plus 1 now, because the bottom canceled. Now for the next one here, I have a 21 and I have a 7 down here. So 7 goes into 7 once and 7 goes into 21 3 times. So this is going to be 3 times x plus 2. And then on the other side, I'm going to get that 42. Because that's 2 times 21, which is 42. Okay, so now what I'm going to do here is just simplify this one. And we dealt with these types of problems already. So I'm just going to distribute here. So that's going to be 7x plus 7 plus 3x plus 6. And that equals 42. So now since I have these x's on the same side, I'm just going to add those together because I have a same sign for both of those. So that's going to be 10x, and it's positive. And then I'm going to add my numbers together too, because those are both positive as well. So that's going to be plus 13, and that's going to equal 42. So now I'm going to subtract my 13 from both sides because I'm trying to isolate my x, which is this term here. And that's going to give me 10x equals 29. Now, my last step here is I'm just going to divide by 10. So x equals 29 over 10. There's our answer for the first one. Now, don't think these answers should always turn out to be nice integer answers. This is definitely okay to have. So just keep that in mind. So now for the next one here. Again, I'm thinking LCD here. So when I look at these two denominators, I have a y and I have a 2y. So the smallest expression those two expressions goes into is 2y. Because this one here is really 2 times y, and this one is y. And I ask the question, what is this one missing here, factor-wise, that this one has? And I say a 2. So that's the idea here. So my LCD here is 2y. So that tells me I'm going to multiply both sides by 2y. The nice thing about it is here on the right side here, those two y's are going to cancel. And I'm just going to end up with 5 over 1, which is just 5. So now for the other side here, this left side, I really have 2y over 1 times 4 over y minus, and then here I can just multiply. I don't have to put it over 1 because 5 is not a fraction. So that's just going to be 10y. And that equals 5 on the other side. So now here, my y's cancel. So I'm going to end up with just 8 over 1, which is 8. So this is 8 minus 10y equals 5. So then I have to subtract 8 because the left side is going to be my letter side. And this is going to be negative 10y, and that's going to equal negative 3. I divide by negative 10, divide by negative 10. Oops. So then my final answer here is going to be y equals 3/10. Because a negative over a negative is positive. So there's our answer for the second one. Now let's take a look at this third one. This third one is going to be a little more difficult than both of these together, really. So the first thing to notice here is these are not going to be easy factors to see for the bottoms. I have x squared plus 2x. I have x squared plus x. And then I have x squared plus 3x plus 2. So yeah, those are not easy to see what those factors are. For the ones before that, like this one here, the 2y and the y, obvious, 2x, or 2y is going to be my LCD. This one is much more difficult. So what I have to do here is factor all the bottoms. So now, what does that mean for this one here, that x squared plus 2x? That means I can pull an x out of that, and that's going to be x times x plus 2. And then for the second one, I can pull an x out of that one, and that's going to be x plus 1. Now be careful. When I distribute back through, it should give back what I started with. So if I do x times x, that's going to be my x squared. And then when I do that x times 1, that's going to give me my x. So when I pull an x out of x, I get 1. So be careful with that one. A lot of people drop the 1 on that one. Now this is the more interesting one, the one on the right here. This x squared plus 3x plus 2. Now to factor that, there's a few different ways to do it. I generally do it by trial and error. They do have an AC method. That's another way to do it, so try to find some way to go back and learn how to factor again if you need to. I can tell right away that these are both going to have to be an x for the first term because I get a 1x squared. And then for the last term, it's a 2. So what two numbers do I multiply to get 2? It's only 2 or 1. So one of these has to be 1, one of these has to be 2. And it's a positive 2, so that means the signs have to be the same. But if you look at the middle term is positive. So that tells me that they're both going to be pluses. Because again, they both have to be the same. And since this is a positive 3 in the middle here, when I add that, 2x and 1x, I'm going to get my 3x. So that's the factors of all three of those denominators there. Now to find the LCD, I just have to look at, let's say, the first denominator here. What is that one missing that the other two have? So when I look at the second one, and I see that this has a factor of x and a factor of x plus 1. So if you notice, this first one is missing an x plus 1. And I look at the third one now. What factor is missing from the first one that the last one has? And I can say no other ones because it has an x, it has an x minus 2, and it has an x plus 1. And that has an x plus 1 and an x plus 2. So there's nothing new that that last one can give it. So that's it for the first one. And then for the second one now, what does the second one have, or what is the second one missing that the other two might have? And I see right away that the first one does have an x plus 2. So this one is missing an x plus 2. And then I realize after that, that now it has everything the first one has. And then for the last one needs an x. Okay, now the reason why I'm writing these all out, and I didn't really have to for the other ones, is because when I multiply... Oh, I was going to try to multiply the bottom by something, but I'm not going to do that. I'm going to do the LCD here. Okay, so that means I'm going to multiply every term. So I have how many terms? 1, 2, 3 terms. I'm going to multiply each term by the LCD. And that LCD, and I'm just going to write LCD here so you can see this clearly, is going to be x times x plus 1 times x plus 2. Now what happens when I multiply every term by the LCD, it eliminates all denominators. That's why I use it. So then what that means is, so for the first one, I'm going to have x times x plus 1 times x plus 2 over 1. And that I'm going to times by x plus 1 over x times x plus 2. Now I'm breaking it down here because I want to see what cancels or simplifies very easily. And I can see that I get this x plus 2 and x plus 2 and this x and that x. So I'm really left with in this problem, when I look at that first term, is x plus 1, and that's from here, times here, which is also x plus 1. And that's the first term. Okay, now I'm going to do the second term here. So that second term I'm going to multiply by everything just the same. X times x plus 1 times x plus 2, and I hope it fits. And this is going to be x plus 4 over x times x plus 1. I'm cutting it really close here. Okay, and remember that's over 1. And then we can see what cancels here. The x plus 1 cancels, and the x cancels. So I'm left with x plus 2 times x plus 4 for that second one. Now notice here there is a minus, so don't forget about that minus. So that's going to be a minus, and then x plus 2 times x plus 4. Now I'm going to multiply the other side by this thing, and I am definitely running out of room here. So I'm going to do this one up top. So this is going to be x times x plus 1 times x plus 2. And then I'm going to use these factored form down here to simplify it. And I can see this x plus 1 cancels, and this x plus 2 cancels. And I'm just left with an x here, and then a negative 3 on top. So then that's going to equal negative 3x. Now we've gotten to a problem that's kind of bearable for us. Still takes a few minutes to solve, but I'm going to multiply this out here. And again, that's the FOIL method that I'm going to use for that. So I'm going to get x squared plus 2x plus 1. Now take your time on that and make sure it works out for you. Skipped a step there for sure. Okay, now I'm going to do the same thing with these two. But notice, I'm still going to use this parenthesis here because I have a minus here. Since I have that minus there, I got to be careful with that, and I want to make sure I leave it in. So this is going to end up being x squared plus 6x plus 8. And that equals negative 3x. And hopefully that's okay with you. If not, let me know. Get a hold of me. Okay, so now I'm going to distribute this negative through. That means all of my signs are going to change for each of those terms inside. So I'm going to get an x squared plus 2x plus 1 minus x squared minus 6x minus 8 equals negative 3x. So then I'm going to combine what I can combine, or just add what I can, since the x squareds are on the same side. I got x's on the same side and I have numbers on the same side. So you notice those x squareds are going to cancel out because that's a positive x squared, that's a minus x squared. So that's going to give me 0x squared. So the x squareds go away completely. And then I'm going to do the x's next. So that's a positive plus 2x, and that's a negative 6x. So that's going to be a negative 4x. And then I'm going to do my numbers lastly here. And that's going to be a positive 1 and a negative 8. So that's going to be a negative 7. And that's going to equal, negative 3x. So then I'm going to move the 4 to the other side. So I'm going to add 4x. So I'm going to end up with positive x equals negative 7. So there's the answer for this one here. Now there's one thing to keep in mind when I have variables on the bottom, and that is make sure it doesn't cause any of the denominators to be 0. And I didn't have to worry about that for the previous ones, because here I had y equals 3/10, which, yeah, I'm not going to get a 0 on the bottom because y would have to be 0 there. So it's obvious to see that. And then for the first one, all my denominators were numbers. They didn't have any variables. So I didn't have to worry about it there either. But for this one, I just look at all the factored forms of my denominators, and I can clearly see that a negative 7 is not going to make x or x plus 2 0. Same thing with x and x plus 1, or x plus 1 and x plus 2. So that tells me that's a good answer. And there it is.